how can we show the bright and dim areas in an image? So let's have a look a little bit. So as I said, the lookup tables help you see. These are tools to help you see. And one of them is change the brightness and contrast in the image. So we have in all macroscopy software, you will have the same thing as this. You will have a way to change the brightness contrast automatically or manually. So this is what it looks like in the Nikon software, and we can drag these triangles up and down. The dark, the one on the left side regulates the dark pixels, and the other one the bright pixels. So whatever is displayed in the image. So we can also do this automatically, and this is what it looks like. So in the automatic setting in general, what you can do is just reset everything. So, or you can also toggle it on and off, or you can have something that auto scales. So what the auto scales does is that it, I will show you afterwards. This one will auto scale only one image. So every time you whichever image is open, it auto scales that one. But you often also have a button that allows you to auto scale systematically all the images that you acquire. So anytime you acquire an image, it comes out as auto scaled. So this is the one that resets, and here is in the manual. They all look very similar. So this shows when you click on the auto scale, then the display is going to show you as dark, like black. It will show you the minimum in the image, and it will show you as white the maximum in the image instead of showing black and white the whole bitmaps. Okay. So instead of showing you 0 is going to be what is completely black, and the white is going to be 4095 in a 12-bit image, it's going to show you black and white only the stuff that you actually have in the image, the dimmest and the brightest pixel. So this is the brightest pixel in the image, and this is going to be 4095 is going to be the maximum possible intensity at 12-bit. So we don't have any pixels in this image that are at the maximum because there's no saturation in the image. And all these things that we have here, because most of the signal is in here, but all the pixels that we are here all the way to the maximum, the brightest in the image, is actually pixels that are in the noise. So all this is completely available in all software. Maria, you had a question.
Yeah, this auto scale is the same as auto range?
Yes. Same thing.
Okay, thank you.
So it would have different names, display, I don't know what. So they all come up with different names, but it's all the same thing, and they all do the same thing.
Thank you.
So try to push the brightest, the contrast and brightness to see the dimmest detail in the image. And for example, when the image is out of focus, this is very useful. If you find the sample in the eyepiece and then you go back to imaging, and then very often there is a difference in focus between your eyes and the detector or the sensor. And then when you grab an image of fluorescence, it's completely black. Do not start changing the focus level randomly, basically, without seeing anything. What you want to do is first push the brightness and contrast, and you will see the sample slightly out of focus. You will see it after you've done that, and then that allows you to refocus safely. This is one of the numerous applications of pushing the brightness and contrast. However, this is extremely useful to push brightness contrast, but it can trick you into thinking that your parameters, your acquisition parameters, are okay when really they are not. So when we reset the brightness and contrast, this is really what the image looks like. So this image is very, very dim. And if you have the brightness and contrast pushed, you may think that the image is okay. But if you look at the histogram, you will see that most of the pixels are very close to 0. So you can see when you look at this histogram that there is something wrong with the image, even if it looks like this because we've pushed brightness and contrast. So look at the histogram, toggle on and off the brightness and contrast and play with that so that you use it when it's needed, but do not let it trick you and think that your image is correct when it's actually very, very dim. So when readjusting the parameters, you need to reset the brightness and contrast, except if you have a 16-bit image, because in 16-bit image, you will always need to push the brightness and contrast. But if you have 8 or 12-bit, you should be able to see clearly your sample without pushing the brightness and contrast. If you need in 8-bit and 12-bit to push the brightness and contrast to see what is in your image, then you need to change the parameter. Your image is very dim. And do not believe your eyes. Check the histogram and check the numbers. So brightness and contrast in Fiji, we go to image, adjust, and brightness and contrast, and we get this guy in here, and we can click on auto, and this is what happens. So then the images are pushed, and do not press this button apply, because in Fiji, when you press apply, it actually modifies the images. So if you want to press apply, fine, but then you save the images again as a new image, okay? So you should only work on a copy of the original image, and always mention any adjustments in your material method. And again, it's not more than the brightness and contrast in the images has been adjusted. So it's a very short way to describe that. So there is something else that people often do not know, and it's called the gamma. So when we look at the lookup table here and the histogram, what we can see is that we have a minimum and a maximum, and that corresponds to the 4-bit depth. But we also have here a number, and so it's in different places in different software, but very often it is represented by a little ball like this that is in the middle of a line that goes between 0 and the maximum bit depth. And that ball, you can drag it either up along the line or up and down. So this is available again in all software. So what you can do with the gamma, so now we have this image, we have an area that is quite dim and an area that is brighter. And that now we are showing the whole bit depth. So we show the whole, we have no adjustments. So we show the whole bit depth, and the gamma is as 1. What we can see is we see the bright areas in the image quite okay, but the dim areas are almost like, it's very difficult to see any details in them. And we would like to display both the dim areas and the bright areas so that people can see details. So what we can use is that we could push the brightness and contrast, but if you push that, what happens is that these areas, so now you can see the details in the dim areas, but the areas that are darkest, they look saturated. They were not quite saturated, but they look saturated. We see these solid white areas in here. So that's not a very good way to do it. And in this case, the gamma is not adjusted, only the brightness and contrast. So instead, what we do is that we use the full range of the bit depth, and we change the gamma. And it's a little bit difficult to see, but this is not a straight line anymore. It's actually a curve. So when we move the gamma up and down, what happens is that we are changing now only the display for the dim pixels and not for the bright pixels. So the bright pixels will still look like they were here, but the dim pixels will look brighter. And you can see this curve is a little bit bent, whereas in here we have a straight line. So here we have a linear gamma, whereas here is not linear anymore. So this is a very good way to display bright and dim areas in the same image without showing the bright areas saturated. When you adjust the brightness and contrast in here, all the pixels are affected in the same way. So this is a linear adjustment. But if you adjust the gamma, the dim pixels are affected and not the bright ones. So this is a non-linear adjustment, and the only adjusted for the dim pixels, and the bright pixels are unchanged. So brightest, gamma, and the contrast adjustments it's no problem doing them, but you must report them. It's very important that you do not show an image like this and not say anything, because then people are going to think that this intensity is actually much closer to this one than it actually is in reality, and that's not okay. So just mention the brightness, contrast, and gamma has been adjusted in the images to show the bright and dim area, and that's it. You just need to say that for the whole paper. Christos.
Yeah, hey, I have a question here. So if we do the analysis without changing anything in the gamma, but in the figure that we will put in the publication, we play with it a bit, is it considered okay or not?
It's totally okay. And I want to say that all these adjustments do not change the data. They only change the way we see the data. So even if you have an image where you have pushed the gamma,
Mhm.
except if you work in Fiji and you click on the apply button, if you don't do that and you work on the original data, you can adjust the gamma and save the data that way. You can always reset. Basically, the rule is like this. If you can reset, then the lookup table is only applied for you to see. And then the data is intact, and so you can analyze them. If you have done something to the image in such a way that you cannot go back, you cannot reset it and go back to having a gamma 1 and a full lookup table, then in that case, you have modified the data. So
Okay.
whatever you have done, you should do it on a copy of the image and not on the original. But this is only a way for us to see things. So it's okay to analyze, and it's totally okay to. You don't even have to say that you analyze. But I mean, yeah, you don't need to say it because you can just mention that brightness, gamma, and contrast has been adjusted in the published images. In the images in the article to allow people to see the images, but you never apply in Fiji. Yeah, it's a bit dangerous. I don't know why they have that really. Chen?
Thank you.
Yes, I have a question about, for example, in this case, some areas of the images are quite bright, but some others areas are quite dim. So in this case, if we want to adjust the exposure time or laser intensity to avoid saturation, we might lose some details of the dim area. So in this case, how can we deal with the situation?
So yeah, you want to avoid saturation. If you have bright and dim areas, if you find it difficult to have enough details in the dim areas without saturating the bright areas, you should change the bit depth. You should go
Uh,
to a higher bit depth and use 16 bits, okay, so that you can acquire many intensity levels without saturation. So this is on the acquisition side. If it's a recurrent problem, if you often have that problem that you cannot see, well, when you acquire an image, you acquire without saturation. And now, if you're interested in the dim areas, change the gamma so that you can see what is recorded, because our eyes are not good. So the information may be in the image and you cannot just see it because our eyes are no good with the dim stuff. So change the gamma to see if the information is in the image. If the information that you want in the dim areas is in the image, no problem. You can stay with 8 bits or whatever you have used. But if you have the problem that either you saturate the bright areas or you lose the details in the dim areas, then go to 8 bits to 16 bit when you acquire.
okay, thank you.
But you see, it's very easy to not, when you do not use the gamma, it's very easy for you to think, oh, I'm not able to, I have to saturate because otherwise I don't see in my dim area. But that's because you're not looking in the right way. The information, there's a lot more information in the image that we can see just like this with our eyes. So we have to use these tools, the lookup tables, we have to use them to be able to see and explore the information. Yeah. So again, this adjusting the gamma will help you explore the dim areas so that you can see if the information that you want is there. If it is not, then change bit depth when you acquire. Go to a higher bit depth. Now I want to show the consequences of underexposure. In this image where I've shown before, where we have a 0 solid in the background. So all the background pixels are set as 0. This is clearly an image that is acquired on a single point confocal with an offset at the wrong place. Okay, when we remove the lookup table that shows the undersaturated pixel, the image looks normal. So it's very difficult to see that there is a problem. However, here I have the same image that is now acquired without underexposure, and they look very much the same. But if I put the saturation and underexposure lookup table here, you will not get any blue at all. So now what I do is that I change the gamma to be able to see the very dim details in these two images. And so I put the gamma at the same place. And what happens, it's maybe a little bit difficult to see on the screen, but if you could look at the PDF, you will see there's a lot of details in this image that we couldn't see before without moving the gamma. All the fine phylopodia and everything are there in the image. They are recorded in this image, but not in this one. But just we couldn't see it. So you have to explore your data a little bit. Right? In the underexposed image, there's no fine intensity details at the cell edges. So explore your data so that you know if there is a problem or not. So in the Fiji, the gamma is under process math and gamma. And this is what it looks like. You can change things, tick in the preview so that you get to see things in the dimmer area in this sample. And in Fiji, always work on a copy of the original. Okay, so you want to acquire everything without saturation and underexposure, and you want to fix the brightness, contrast, and gamma after acquisition, and you always work on the copy of the original image, especially in Fiji, because it's easy to change the original data, which is not so good. So here we have the raw image that we have now acquired with no saturation, no underexposure. And this is the first image that I showed you where this one was saturated. These were very, very dim. And you can see that we can completely fix the display in these images and make them look really nice by just changing the display. That's not an issue. So just work on your images afterwards if you want to make them look nice for publication. Okay, here are the conclusions of this lecture. So the bit depth determines the number of possible gray levels in the image and is not the maximum intensity in the image, okay? As long as we have no saturation, the maximum in the image will be lower. So choose the bit depth to match the need of your experiment. If you want a high speed, choose a low bit depth. And if you have very high and very low intensities in your sample, then choose a high bit depth. And then you lose the speed. But set the imaging parameters to have no saturation, no underexposure at all anywhere. Oh, this comes later. And turn on the mask. I think I've said that before. If you change the lookup tables, it doesn't change the data. So it only changes how the data is displayed on your computer. So play with this, don't be scared of it. Explore your data, push a lot the brightness and contrast, change the gamma so that you can actually see what's going on in the areas where your eyes are not good enough to see. And also look at the histogram to choose the imaging parameters. Do not believe your eyes and make sure that you don't get tricked by the lookup tables thinking that your parameters are okay when they're not. And change the bit depth from 16-bit to 8-bit if you want to be able to open the images in the non-scientific software. But all the scientific software, even image analysis, they will read the 16-bit as well. It's only if you want to display it in make a PowerPoint or something like this. And only change the bit depth on a copy of the original, okay? Because this is a final, you will modify the image if you change. So do that on a copy of the original. Always mention in your paper the modifications that you have performed. Again, it doesn't have to take a lot of space. You can say things generically for everything, but at least that shows to the reviewer that you know what you're talking about. So that's it. This is for afterwards. And I would like to know if there are any comments.